So welcome to this workshop. The official title is Schema Transformation in Reality for INSPI, the NMCA Experience. I have added a subtitle, Schema Transformation, an history of trees and table. Of course, it's not so official, but I hope it's a little more mysterious and maybe more attractive. So I will begin by a question, what comes first? Generally, this question is about eggs and chicken, but for this time it won't be about eggs and chicken, but of course about trees and tables. Of course, in real life, in nature, the tree comes before the table. But for schema transformation, you need some patience, because now I am going to come back to the official title. This NMCA experience, where does it come from? It comes from two main sources. The first source is the ELF project. ELF means European Location Framework. Maybe. And from the INSPI-CAN, that is the Knowledge Exchange Network. What is ELF? ELF is a European project. It's supposed to last for 3 years. It began in March last year and should end in February 2016. There are around 30 partners. NMCAs, for those who do not know what NMCA means, it's National Mapping and Cadastral Agencies, and Eurogeographic, that is the association of NMCAs. There are technology providers. Among these technology providers, Snowflake, that is involved in schema transformation, but also SRI, One Special, Interactive Instrument, and others, universities, application developers. This project is co-funded by the European Commission and the consortium partners, and the main objective is to offer a single point to harmonize data and services from NMCAs. Some graphical representation of ELF. On one side, we have the source heterogeneous NMCA data, and the objective is to provide harmonized ELF data based on INSPI schemas. It's an NMCA profile of INSPI to offer ELF services, and from the ELF services, they will be available for application developers. But of course, there is a gap between the heterogeneous NMCA data and the harmonized ELF data, and this gap is going to be filled through schema transformation. The other source of the workshop is INSPI-CAN. INSPI-CAN is a knowledge exchange network. It's a Eurogeographic group that was launched in 2011. It's open to any NMCA staff having interest in INSPI. And the main objective is just to help one another by sharing our experiences about implementing INSPI. Our activities, it's exchanging knowledge on Basecamp. It's our typical website through webinars. For instance, we organize some webinars about cloud computing, but also about service protection, authentication, authorization, and accounting issues. And we had workshops. We had, for instance, workshop about review of Annex 2 and 3 data specification, about INSPI services, about the strategy to implement INSPI, one about schema transformation, and recently about coordination between producers. Of course, it's this workshop about schema transformation that is also a main source for the workshop today. What about this INSPI-CAN schema transformation workshop? It was held in Paris in October 2013 with the support of EuroSDR. The objectives were to present a wide range of tools and methods for schema transformation. This presentation might be either from tool developers, but they might be also user experiences. And it was not only to present this wide range, but it was also to try to extract relevant criteria to choose the most relevant methods and tools for doing so. We were around 50 persons attending this workshop. The agenda was very busy. There were at the beginning some general presentation about schema transformation concepts from one of my colleagues, Marie-Lise Vautier. There was a very interesting presentation from Thorsten Reitz from the previous Humboldt project about languages for schema transformation. There was also a very interesting presentation from Lassie Leto from the SDIN project. SDIN project was a precursor of ELF project, giving the results of SDIN about schema transformation. We had then a series of presentations about use of web feature service, the possible way to use web feature service for schema transformation by Frank Arnsten from Kartverket. We had a presentation about degree from Sebastian Goerck from Lathlon, that is the editor, the software developer of degree. And we had also a presentation about the use of GeoServer and GeoServer application schema, that is a specific plugin to be used for Inspire, from my colleague Marie Lambois from IGN France also. We had then the afternoon devoted to open source tools with presentation about XSLT for Inspire transformation and with Tetel, that is in a way encapsulating XSLT in the schema transformation from Just van den Broek from OSGeo. We had a presentation about talent that was used in the Plan for All project by Jean-Loup Delaveau from France, from Certu. And we had also a presentation about GeoKettle, a test with administrative data from my colleague Edith Votard. Still about open source tools, GeoConverter for Inspire, Pedro Mandi from Tracasa, I think he's in the room. We had also the use of EL, the Humboldt Alignment Project from Thorsten Reitz. And we had also a presentation about, I don't really know how to pronounce it, but it's a tool developed by the BRGM, Euro GeoSurvey of France, from François Tertre. We had also presentation about commercial tools, about Intergraph. For Intergraph, we had the presentation both by the software provider, Intergraph, and an experience by Gugik in Poland using it. We had a presentation from the user side of Altova MapForce from Hélène Eriksson. And we had also a presentation about One Validate, One Integrate of Bob Shell from One Special. Of course, we could not forget FME, that is widely known. The presentation was done by Ken Bragg, transforming data with FME for Inspire. We had also the presentation about ArcGIS for Inspire from SRI, and about Go Publisher from Richard, who is here. And the last afternoon was devoted to research and future, model-driven WFS from the University of München, from Tatiana Kutzner. We had also a presentation from one of my ex-colleagues, Sandrine Ballet, who worked in Cogit, about involving semantics in schema transformation. And the ARENA project was invited to the workshop to provide also some work about this project and how they might be involved in schema transformation. So they were really 2 very busy days, and the attendant to the workshop had few time to enjoy Paris. So the results the result is a big amount of knowledge. All this presentation, and there are also video records, they are available on the public website of Eurogeographic. They are available for everyone, not only for NMCAs. The title is, the address is here. There has been also some discussion following the workshop. This discussion has gone on the data harmonization panel because it was more open to everyone. Our Inspire Ken Basecamp is only for NMCAs, and as the workshop was open to software providers, the discussion gone on this data harmonization panel. And one of the main findings of this workshop is that schema transformation is an history of trees and tables. And now you can make the link with the subtitle of this workshop. Why? It's because the schema transformation may occur at different levels of abstraction. It may occur, of course, at conceptual level. The conceptual level is platform independent. It's just modeling the real world according to a meta model, for instance, the general feature model. It's making feature types such as buildings, having properties such as height, elevation, use, and so on. But generally, the schema transformation occurs at logical level, that is platform dependent, that is depending on the software, on the tool you use. And the main issue comes from this logical schema. Why? Because at the beginning, it means in source data, what is it? The table. Of course, not this sort of table, but this kind of table. Most of source data, as I said, have a logical model that is based on a tabular structure. Generally, we called it a relational database. And at the end, as the Inspire model, I have chosen one, the name place for geographical name. It's a rather simple one. In this feature type, we have some attributes that are either simple, such as date, time, or code list, but we have also data types. For instance, the Inspire identifier, the related spatial objects that are both identifier. It means an attribute that is itself composed of other attributes. We have, for instance, the geographical name. It's a data type that is composed of other attributes. Some are rather simple, such as character string or code list. But for instance, the spelling of name is itself a data type composed of sub-attributes, and such for the pronunciation of name. So, Inspire model have a hierarchical structure. It may be seen, for instance, if it's displayed in the Humboldt alignment editor. If we see this structure in GML, at the top is the name place, it's the feature type, and we have some attributes, and some attributes, such as the Inspire ID, are themselves composed of sub-attributes, and the same for geographical name, composed of, for instance, the spelling, some simple attributes, and the spelling of name being itself a data type. So we have this hierarchical structure, and this hierarchical structure may be represented, I will say, you think it's a triangle, but in fact it's the trunk of the tree, it's the feature type, the data type as the branches of the trees, and the leaves, of course, as the atomic attributes. So we have to go from a source data that is in a table structure to a hierarchic model in a tree structure. It's one of the main issues of making schema transformation for Inspire. So there are three main methods to do so. The first one is just to do it in one step, to go directly from the table to the tree. The second method is to make most of the to do in two steps, to make most of the transformation in a table structure, and then to transform it in a hierarchical, in a tree structure, in a GML structure. And the other one, of course, is the opposite. You go first in a tree structure, in a XML, GML environment, and you make the transformation in this hierarchic structure. And so, the agenda of the workshop is very simple. There will be first a presentation from a very sportive man, Richard, that is able to jump in just one step from the table to the tree using Go Publisher. The two-steps approach by making transformation in relational environment will be done by H Mellum, the man who likes tables and who make most of the transformation in this table environment. The two-steps approach by making transformation in a XML, GML environment. Normally it was just Vandenbroek from OSGeo, but unfortunately he could not come, so I am going to replace him, and I apologize by advance because I have tried to make a presentation extracting from slides from the presentation he gave during the Paris workshop, but okay, I apologize, and I will provide the conclusion and other findings from the workshop at the end of the workshop. So now I let the floor to Richard, the sportive man that is able to jump from the table to the tree in just one step. So I think I have first to equip you.
See how sportive I am. Does this work? Yeah? Okay, brilliant. Thanks for the introduction, Dominique. Being introduced as a sportive man is is interesting. I just returned from holidays and I did 2 weeks absolutely nothing on a beach. So yeah, my name is Richard Rombouts. I work for Snowflake Software in the UK. We are a UK and US based SME, and we provide solutions around data exchange using open standards. And we are involved in the ELF project to provide data transformation tools to the NMCAs that allow them to transform their existing data sets, the tables, to the ELF specifications, to the tree, so to say. So we're going from tables to tree in this presentation. Let me just skip this slide. Just to tell us a little bit of what we do at Snowflake. So we develop software, turn it into off-the-shelf products, and we provide some training around those products and about open standards as well throughout the world. Just a little bit about what we do within the ELF project as a commercial partner. We are involved in work package 4. ELF project is quite a large project. It has about 9 different work packages, and we are involved in just one of those. And we provide the part of the package that delivers geo tools to the consortium, to the project. And we are focusing on the data harmonization tools. Other partners are responsible for delivering different kinds of tooling to the project. Think about tooling around edge matching, generalization, data quality checks, that sort of things. But in this presentation, we'll focus on the data transformation tools. Apart from provide the NMCAs with some tooling that they can use, we also work with the NMCAs in getting them up and running with the tool, to train them, or even what we've done previously is take some data from the NMCAs and we do the transformation in-house in Southampton at Snowflake. And of course we also while we're doing the data transformation, at the same time, we're looking at the ELF data specifications to make sure if they are fit for purpose, if the data transformation tool actually can work with the ELF specifications that have been delivered by another work package. And of course, we participate in different sort of dissemination activities like here. So how do we approach this data transformation tool? As Dominique mentioned, we take the one-step approach without tooling. On the left-hand side is a good old table. I just pictured it's slightly different. Instead of a table, it's a bit of a box and container, which is the legacy database. Most commonly, that is a relational database, a spatial relational sort of database. Think about PostGIS, Oracle, SQL Server, that sort of large enterprise scale and spatial databases. On the other side, on the right side, there are the ELF specifications, the XML application schemas that have been developed in the ELF project. One thing to notice as well is within the ELF project, we didn't decide to just build our own little specifications totally on our island on our own, but instead we took the Inspire specifications and extended them. So we took Inspire, because there's a lot of work within those specifications, and extended those specifications to fit and to meet the requirements of the ELF project. So the great thing is that when NMCA is starting to publish ELF's data, ELF conformed data, they're also hitting those Inspire requirements. The tool we are using in this case is Co-Publisher Desktop. That's a piece of software that we develop at Snowflake and provide for free to the participants in the ELF project. And what we do with Co-Publisher is Co-Publisher connects, sits between the table and the tree. I'm not sure what sort of acronym we can use for use of that, but what sits between the table and the tree? A slide. But basically, Co-Publisher sits between those elements, and you connect on one hand to your database, and on the other hand, you connect Co-Publisher to your schemas. And you set up your data transformation between the tree structure, the the table structure on the one hand, and the tree structure on the other hand. They're quite different worlds, as Dominique explained. A tree is not a table. They're quite different sort of technologies, different ways of describing data. And Co-Publisher allows you just to map those elements, the tables and the columns and the joins in the table structure, and you can map that against the hierarchical sort of tree structure in an XML schema. Of course, after you set up your data transformation, you publish some data. So Co-Publisher then reads data from your database table and publish it out directly into an XML or an GML document that is valid against your tree structure, against your XML application schemas. And that's very important to have this check, to make sure that whatever you publish is valid against your schemas. Because that gives you a sort of data quality assurance about that you're doing the right thing. So let me just go into some slides and talk a little bit more about how we do those one-step transformations, and go to some sort of scenarios that you will come across when you start doing those data transformations yourself. The very first start is when we start transforming data, is to think about don't touch any software. Just sit back and try to understand what I'm trying to do. I have a database structure, which is quite often very complex, a big relational data model, sometimes with hundreds and hundreds of tables, very complex relations, into what often is quite a complex XML hierarchical structure. And one of the lessons learned from the precursor project from ELF, the project called SDIN, is to use what they call matching tables. And a matching table is quite a simple thing. It's just an Excel document with, on one hand side, your database structure, on the other side, your XML structure. And you start to put some words against it. You start to describe your mapping in normal words. the great thing about that is you don't have to be a software expert or necessarily a software developer to understand these things. This is quite often done by a data modeler, someone who understands the data sort of transformation side without maybe understanding a software or a coding of software. So the great benefit of using matching tables is it's transformation tool agnostic. You can just give an Excel sheet to be used in Snowflake software or in FME or in OneSpatial or in open source or in XSLT. Everyone can use those Excel matching tables. They're really, really valuable. One of the things we did a couple months ago, we took some data from IGN France for 2 departments, and we were provided with an Excel sheet with a matching table. And IGN France asked us as Snowflake, can you please just use the matching tables and make the mapping? Without those matching tables, I could say we were not able to do this because we didn't understand the database model. It's all in French, first of all. We speak French at Snowflake, but to understand the database model is quite tricky. And the matching tables are really, really big benefit. I'll show you an example in a moment. So it's easy to understand, and there's no sort of expertise needed to understand those matching tables. I have a horrible screenshot, but let me just show you the real thing. I hope you can see it in the back, roughly. You've probably seen those things anyway. But this is a matching table. Let me just zoom out a little bit. But on the one hand side, I know you can't see it, but I just described the high level. On the left hand side, we see the XML structure. So this is the sort of the target where we're transforming to. On the right hand side, we see the source database structure in tables and columns and that sort of things. And in the middle, in the green column, the data modeler described the transformation methodology that we have to apply in the transformation. Let me just show you some examples. So what the data modeler put in there. Little notes like, okay, there's a begin lifespan version. Everyone who worked with Inspire models knows those terminology, I hope. Begin lifespan version. Basically say, well, it's avoidable sort of attribute. Just put in there the value unpopulated. Great, that's easy. That's very useful for us to know when we do the transformation. And this little equal thing, geometry. This means just take whatever is in a database, don't do anything fancy with it, but just push it out again in an XML or in GML structure. I wish it would be that simple throughout the transformation. There are some really, let me see, this one, an interesting one. A lot of question marks. That's an interesting one for us too. And that's why we have the conversation back with IGN France to ask, what do you mean with this? It is quite a simple transformation. I can show you examples where there's a lot of sort of logic involved in there. Say, okay, where this particular value equals this, then put this value there. If there's another value, put this value there. If it's another value, just ignore it. So, good example, IGN France contains, manages data from outside of Europe as well. In this case, we're not interested in transforming any data from, for example, Martinique or Guadeloupe. But the database holds this data. So we had to filter that out. So this is a typical example of a matching table. I believe the templates of the matching tables are on the Eurogeographics website. I believe maybe on the ELF project website. They're definitely on the SNU. That's definitely worthwhile looking at because it gives you a good sort of first approach at data modeling without touching any software, without any coding. Just do a bit of mapping in an Excel sheet. So how do we do it in CodePublisher? Just show you what we do in CodePublisher. Show you some examples of transformation scenarios that you come across. So this is the CodePublisher tool. It's a desktop tool that you install locally. And let me just open a project. And what you see on the roughly how it's being built up on the left hand side, in this case, you see, hopefully you can see database. If you can't see, I'll explain it anyway. On the left-hand side, the column is the description of the database. So Go Publisher, on one hand, connects to a database and reads all the tables and the relational model from that database. On the right-hand side, so these columns here, XML part, type in XML, this is where you connect it to your target application schemas. So the ELF schemas or the Inspire schemas, or to be fair, we don't really care about the target schemas. It could be any XML application schema. Go Publisher is very generic. It's not tied to Inspire as such. It's a very generic tool. You can use it to publish Inspire data, ELF data, any of your national models. We don't really mind which model you use. So on the left-hand side, you see the different tables. And in this case, we're just transforming some address data. Very sort of straightforward address data from IGN France. The nice thing is that the database we received with address data had one table called adres, which is French word for address, I learned. Sometimes different languages are reasonably easy to understand. I've seen some data sets from Taiwan. It's more complicated. But what we've done here is, this is a table, and we start to put in some filters on the table, because in the ELF specifications we have to split out addresses in different sort of feature types. So we have to split out an address into thoroughfare names, address area names, admin unit names, etc. So we have to split it out from one table into many different feature types. And that's what we do using all kind of filters. So on a table, we have the table address. And in this case, this is information we received from those matching tables. It says if a particular column, in this case nom voix, I don't even know what it means, but it was in the matching table. It says if it's not null, so if that value is not null, it's not empty, then this address bit of data must be a thoroughfare name. If nom_ld is not null, it must be a address area name, etc. So this is sort of intelligence we started to build in the transformation. So that's on the very high level mapping of the tables. So you map a table against, in this case, a feature type in your target XML schema. Of course, we didn't start typing this old sort of stuff in. Go Publisher gives you a nice little drop-down list to choose from. It reads directly from your application schemas, and it only shows you the sort of the relevant things you can map to. Let me just open up one of those tables. Address. You can see it becomes a bit more complicated. So on the left-hand side, we have some columns. These little things are columns from the database. If they are gray, we just ignore them. So what we see is that the database we received has a lot of information that we don't actually need for Inspire or for ELF. So we just ignore them. We just don't map them at all. Another thing you'll see is those little brown little C's there. Those are what we call constant values. So quite often what you see in your data transformation is that your target model requires you to publish some data that you don't hold in your source database. Instead of going into your source database and edit your database, which is something you don't really want to do because that's your legacy database. It underpins quite often your enterprise. You don't really want to start hacking in that database just for Inspire. What we do in Go Publisher, we set up a little constant value. So that is a little value, a little bit of data that will be generated on the fly when you publish the data. So you don't touch your source data. That's the key sort of aspect of what we do in Go Publisher. Don't touch your source database. We will stay away from that. So I start introducing those little constant values. So we have something called a begin lifespan version. It's one of those typical things that no one, I believe, holds in their source database. But it's required for ELF and therefore required by Inspire. And in this case, the matching table said, if you see something called a begin lifespan version, just say it's unpopulated. And that's what we did. That's what we created this little constant value. So whenever we publish some data to the begin lifespan version, we just put the value unpopulated in there. Another interesting one is the Inspire ID. The Inspire ID is a complex type. It's a combination of different bits of data pulled together in a single property. And what we've done here is a bit of a combination of things. Let me just hope you can see. The Inspire ID consists of a local ID, a namespace, and a version ID. The local ID was, yeah, we could find that in the matching table. We had an existing column in the database called INSECOM, which is a sort of identifier from the French Department of Statistics, I believe, something like that. Or it's a particular ID, yeah. It's a particular ID. We put a little separator in there and another identifier. So we put the local ID consists of 2 bits of existing data with a separator between them. And we add 2 other constants to build up the Inspire ID is the namespace and the version ID. Again, I don't think anyone holds the namespace or manages the namespace in their legacy database. Again, this is something very typical for Inspire and therefore ELF, and we just put some constants in there. And slowly you start building up your transformation this way by mapping tables against your XML structure. So your table structure against your tree structure, using little pull-down menus like we see here. One of the things that is quite important is you want to check your work, your transformation while you're going, because you can spend easily a day on a transformation, building a very complex transformation. It depends a bit how good the matching tables are, to be fair. And in the end of the day, you click the button publish and you say validate and it says error. And you go, oh bugger. So you have to go all the way to the beginning and find out, oh, what's wrong? Oh, I forgot my local ID here. Oh, map it again, publish all the data again, and then find out, oh yeah, the comma was supposed to be a pipe. Oh, go back to my transformation. And you spend hours in just fixing little things. What we do in Code Publisher is we have this little preview screen in which anytime in your transformation you can hit a preview. And it just shows you, let me just make it a little bit bigger, a bit of sample data from the database. And it just gives you a nice sort of overview if your sort of the nesting of all those elements is right, if the data you expect it comes out to the right sort of manner, if your IDs look alright, if the attributes are filled in properly. So you can just have a quick sort of indication if your mapping is correct. So you don't have to complete your complete mapping and then find out you made errors. You do that, I would say, on the fly. You're just constantly doing this. And of course you can validate your preview as well. I probably got some errors because I've been doing some messing around with them. But you get some nice little warnings, error messages. So we validate this bit of sample against your application schemas. And you have to essentially resolve those little things until this says XML is valid. Then it's thumbs up, you open a bottle of champagne, and you celebrate a little bit. Well, that's what we did, actually, but other drinks are available. But you can see here, this is where we start building up this transformation. If you're interested in how long it takes to build this transformation, this took us, this is something that one of our junior consultants did. This is quite a complex one, it's about a day and a half, roughly, to do this transformation, make sure everything is correct. And in the end, when we made sure that the transformation is correct, we hit the big publish button and we start to publish the whole data set out. And then you find out that these data sets can be quite big. Back in August last year, we did some European data sets from the Eurogeographics data sets. And I believe, Roy, how big was the regional map again?
I don't remember.
20 gig, roughly?
The GML files. So.
Yeah, the GML files. They can get quite big. One little advice, by the way, if you're a bit concerned about the size of GML files or XML files, zip them. WinZip, gzip, they're great compression tools, and they make the files roughly about 20 times smaller than XML, than the normal raw XML file. There's a lot of air in an XML file, so they compress really, really well. There are many other different sort of transformation scenarios you can think about, but I just show you the most common ones. If you're interested in seeing more, just come see me today or tomorrow morning. So what we then, experience we have with publishing data against the ELF specifications. Well, first of all, we provided the tool to the consortium, to the different NMCAs, and they are free to choose if they want to use the tool or not. So some of the participating NMCAs use their own tools, or they use they build something themselves, and other organizations decided to use the tool that we provide to them. So they're using co-publisher. So we transformed some Euro geographics data sets. Those are quite large European data sets being managed by BKG in Germany on behalf of Eurogeographics, and we are in the process of transforming data from IGN France for 2 departments. Very nice departments, by the way, I should say. We got department where there's Saint-Tropez, Nice. That's a really cool sort of, it's a bit geeky, but it's quite nice to transform those data sets just because a nice area of the world. So some of the experience we have with data transformations and using ELF specifications and therefore Inspire specifications, and using national mapping agencies' legacy databases. Matching tables. If you are beginning to look at transforming data, those matching tables are really, really good start point to start thinking about transformations without being dug into software, because software sometimes is a bit tricky to use and you spend a lot of time in learning the software while you should focus on learning your data transformation. So use those matching tables. Even though if you're using your own tools that you already have in-house, or you want to give it away, to outsource that work, create those matching tables. We transformed some data sets, the European data sets, back in August and September as a sort of first sort of proof of concept to see if the tool is working, if the specifications are ready to be used. And we started to transform some master level data from IGN France with the matching tables again. And a couple months ago, March I believe, I went over to Frankfurt to train 2 people at BKG to use co-publisher to transform their European datasets, the Euro geographics datasets, the Euro regional map, Euro boundary map, and Euro global map that they maintain, to take those datasets and transform them against the ELF specifications. And the great thing is, I only spent 2 days with them, and after day 2, they were quite happily just already transforming and creating some datasets with some. This shows you how the learning curve is quite low. So you get up and running quite quickly with the tool. And BKG will continue just transforming the data with a bit of offsite help from us when needed. Further down the line in ELF, the different national mapping agencies can call on us to help them out with transforming data. I believe we start hopefully soon some conversations with the Polish and the Czechs, I believe, on transforming some data, and hopefully the Spanish as well. I believe I saw the Spanish National Mapping Agency somewhere. So what's the great thing about on-the-fly transformation? In this case with co-publisher, other tools are available, but I'm Snowflake, so I'll talk about co-publisher. The key thing is with on-the-fly transformation is you don't need an Inspire-like database. So our solutions are there. One of the sort of the method that Dominique will talk, or Roy will talk about, is having the Inspire-like database that is closely related to your Inspire schemas or to your ELF schemas. We don't do that with co-publisher. We just sit directly on your legacy source database without touching it. And you set up the transformation between your quite different legacy database and your ELF or Inspire specification. And the great thing is that you have a very rapid transformation. It's quite quickly to set up those transformations, create little previews, and find out if you're doing the right thing. A good example is the National Mapping Agency of, or I should say the National Data Agency in Denmark. They've been using Co-Publisher to build their Inspire web services and Inspire sort of data transformation using Co-Publisher. And the main reason for them to use it was just quickly to use. One thing that all of you, I think, involved in Inspire have noticed is schemas change over time. There are draft versions, there are version 1, version 2, version 3, version 4. Things will change over time. And what Co-Publisher will allow you to do is just point to the new schemas and map the differences. So you don't have to go back to your supplier, ask for a new Inspire-like database because new schemas have been developed. Co-Publisher is very generic and agnostic. It just sits in between your database and your schemas, so we don't really care about changes. You just point to the new schemas or to your new database and map the differences. Validate as you go, I just called it, is basically just what I said. You're continually just validating your data while you're building your transformation. It gives you a very quick insight in if what you're doing is correct. And there's no coding expertise required. You don't have to be an expert in XSLT or Java or C to develop something. It's just all point and click. The only caveat I should add is a little bit of database knowledge or SQL knowledge would be great, because sometimes you do some quite complex things in Co-Publisher where you can start embedding complex SQL queries, or you can even start embedding Java code and XSLT if you want to. Just want to summarize or finalize on this little slide is when you start doing data transformation is sometimes it's good to look outside of the box. Look out, you do more than just Inspire or ELF. Many of the national mapping agencies involved in the ELF project also have other obligations. They have to publish the data against maybe other national or European initiatives or directives, and that's why it's good to have a generic sort of tooling that you can use to build transformations against all those different other schemas or different sort of directives without touching your source database. That's the key thing, because you invested a lot of money in this. It underpins quite often your systems, your enterprise, your business. So you don't want to mess around too much with this source database. That was my talk about on-the-fly transformation. Those are my contact details. Again, I will be here until tomorrow afternoon. Then I head back again. I think we got some questions at the end of the session.
If we have time, yes.
Sorry. So I just hand over to Roy. And Roy will talk about the two-step approach. Roy, by the way, is a real sportsman, not me.
Change the equipment.
Let's have a look.
Okay. Does it work? Yeah. Okay. I will give you this presentation based on first I would like to introduce myself. I'm heavily involved in the ELF project as a work package leader of the work package, being responsible for delivering the contents in ELF. That means both data and services. So one of my main tasks now is to, shall we say, guide and push the national mapping agencies in getting their data transformed and published as web feature services mainly. So we have been working with this for almost half a year in something we call the Nordic cluster now, and I will give you some of our experiences and tell a little bit about our approach in there. So the Nordic cluster, it was established as some sort of a task force in the ELF project. We are 3 countries, Finland, Sweden and Norway. And our main tasks was to actually develop / prototype national download services. And then we are talking about real detailed data, the most detailed data the NMCAs have. Yeah, and they were supposed to be delivered with GML 3.2.1 encoding. So in early December, we got the first ELF specification, which is a profile of the Inspire specification. So if you are compliant to ELF, you are also compliant to Inspire. We have selected 11 teams from Inspire, which are the ones the National Mapping Agency normally holds. Yeah, and I would also like to say that it was the fact that none of these 3 countries had very much experience in schema transformation and web feature service setup in December, actually. We had some experience from previous project, but very limited. So what turned out to be was that we also have chosen the same approach for the schema mapping and service setup, and also have chosen almost the same tools in our environments. Yeah, this is more or less obvious, our focus. We want to be very close to the source data in our delivery point. As few steps as possible. He's the one who has the fewest, perhaps, but and of course we as NMCAs we consider ourselves as authoritative sources and also up-to-date sources of data. Full Inspire GML, and we also decided to use open source software where we can. That's also according to some central Inspire principles. Here's a sketch where I'm trying to, I call it some sort of architecture, but what it's more about is try to visualize the possible approaches to schema transformations. Starting at, so the schema transformation is actually here, and of course you have some database down here and some clients consuming the web feature service here. So in between here is actually the schema transformation era. So what Richard was talking about was the leftmost approach directly from the database to the GML. What I will talk about is actually more in here. So we have actually 2 approaches for the 2-step version. That's with database views or using database tools producing a distribution database. And then we are using the functionality in the WFS service to actually, shall we say, map the database structure to the GML structure. We have also added on the right-hand side a box called other methods, because we do believe there also are other methods which we have not thought about yet for this. So our approach, it's more or less the same as Richard was talking about. We see this in 2 levels. The first one is on the model level, where actually this is where you use the mapping tables. And that work is normally done by domain experts and data modeling experts, because you have to know UML, and you also have to know your own data structure to do this work properly. And how we have done, I would like to emphasize that we have actually, in Norway, we have set up small groups with all the types of resources that will be involved in this schema transformation process, and made a more used a more Scrum-like method to do this work, and that made us quite fast ahead with this work. And it also definitely made us quite sure that there were no misunderstandings between the different skilled persons in here. This is very important from my point of view. I also have some slides on schema mapping. I will not go into this because Richard also did. But again, that's a prerequisite for this work, actually. That you use the methodology with the mapping tables. So the first approach I will go a little bit deeper into is the approach where you are transforming into database views. I believe most of you know what view is. That's a more, shall we say, a virtual representation of a subset of a database, which still resides within the same database. Yeah, so here we do most of the transformation down in the database here, and the rest up here. I will come more back with details to this later. So, and what is important here is that the transformation is actually processed live from each request down to the database. And we think it can handle rather complicated transformations in this way. So here's just a simple example of how, here are the tables and here are the views where you have, by some simple SQLs or something made, build up the view from the production database. It's rather simple. I will skip this. So here's the next one where you do some actually scheduled transformation made by database tools like SQLs or something like that, other tools. Of course, this approach gives a new copy of your data as a inspired tailored distribution database. For some data sets, we have also used this approach actually, and not only used. That was due to the character of some of the production systems that we had to do it this way. And it has many of the same characteristics as the view concept, especially with respect to handling complex transformations within this approach. And the last one there is perhaps also important with respect to performance. That here you have a completely tailored database, which will, in 99% of the occasions, I think, will give better performance than if you are using views. Okay. So here are the software tools we have chosen. In most cases, as a WFS server, we use Degree. That was the best one, and still is, for supporting the requirements we have for both for the service conformance and also for the data conformance with respect to Inspire specifications. I must say that we also have a very close dialogue with the developers of Degree at the time being. I also think you in France have chosen Degree as a WFS server now, Dominique?
I think it's,
Yeah.
we are moving from GeoServer.
Yeah, yeah. And in most cases we are using PostGIS as a database because it's open source, and they have also come with the materialized view functionality in the some of the last versions. But in some cases we also, for special reasons, we also use Oracle. So I will not go much into detail with Degree, but one very central concept there is the so-called feature store. That's where you are actually reading the application schemas and create the feature store, so we get one table for each feature type you have, and that is used then again in setting up the mappings to the GML. And it's quite flexible in the support of mapping GML application schemas to relational models. This is somewhat like what you do in Go Publisher also, Richard. And then well, this is the panel of Degree actually, which you see here. And here we have just said that we will have a relational approach to our mapping. So there is a process we have to go through. I will not go through that process here because I think that would be too detailed. So what have we achieved since the beginning of September? As you remember from my first slide, we had almost no experience in doing this, and the learning curve has been quite steep for us. And that is based on the fact that not many mapping agencies had even started their work with implementing Inspire download services yet. So we have actually achieved 6 services now, delivering very detailed data on administrative units. Addresses, we have 3, cadastral parcels 3, geographical names. Well, you can say what you like about those 4 first ones, but they are the easier ones. So these are also the 11 themes which we have chosen to include as content in the ELF platform. The content in the ELF platform shall be finished by 1st of March next year. So we have 8-9 months to go. That involves quite a lot of work for the National Mapping Agency. I mean, it is not rocket science, but it's still quite complex things we are dealing with here. But it's, I think we are moving faster and faster and faster in the NMCAs in solving this now. That's it.
Change of equipment.
Yeah.
I'm not sure. It looks curious. I hope it will work. Yes. So it's a presentation that just should have given. The context is that it was schema transformation that was done within the SDIN project, that was a precursor of the ELF project. It was tested, it was used to test Annex 1 themes, and the tests were performed by Cadaster. And it was also made using open source tools. Just is I don't know exactly his role, but he's a promoter of USGeo. He's quite involved in USGeo. So the overview is that there is source data in an Oracle database. This source data is extracted to GIS files. Then it follows the transformation process that I will detail in the next slide. And then this GML inspire data is published and goes to Postgre to be stored and to be served later. So let us see now each step of this transformation process. The first step is done via OGR. So at the beginning there are these tables, map info or shapefile tables, and the result is simple feature GML. It's exactly the first step of the transformation from the table to a simple tree without any branches. In scientific terms, it's called simple feature. It means simple geometry, 2D, linear interpolation, and simple attributes that are directly character string, integers, and things like this that are directly attached to the feature type. So the tool OGR makes two things: the coordinate transformation. It's not the topic of our workshop, but nevertheless it has to be done for InSpy, and the format transformation in a way to make the transformation from the table to a simple tree, to a simple structured XML structure. What is OGR? OGR is a subset of GDAL, Geospatial Data Abstraction Library, that is a library to translate raster and vector formats. It's an open source and licensed by the Open Source Geospatial Foundation. And sometimes GDAL is more used for raster transformation and OGR for vector format. So OGR is the vector part for simple features. The second part of the transformation, it's done using XSL, or more exactly XSLT. So at the beginning, as a simple feature in GML, the simple tree with the direct attributes attached directly to the trunk, and the result is the InSpy Annex 1 GML. So in this InSpy hierarchical structure, so the XSLT, it makes the model transformation by transforming the concept, but also by implementing this different logical model with all the branches. XSLT is basically a tree transformation. It's the words of just, I have not invented them. The input are well-formed XML document, and the output are also XML document, but they may be anything text. But in InSpy concept it's XML, or more exactly GML. XSLT, what is it? XSL, it's for Extensible Style Sheet Language for XML document. It's a standard for Web3C working group, and this standard was split into 3 standards, and XSLT for transformation is one of these standards. The principle for XSLT, the input is one file or several files in XML, and the XSLT code that is run by an XSLT processor, and the result document that is also in XML or in GML. The advantages of XSLT, it's a standard that is quite well established, it's quite mature, stable. There is lots of knowledge about it on the web. I will show the third advantage, XML based. So it's in a way the tool uses the same language as the source and as the target data. So it's also an advantage. And it's use compact, reusable style sheets. The drawbacks is that XSLT is rather complex because it's mainly declarative. It means declarative that you describe the logic of the computation but without describing each step, leaving the processor some place for optimization, but it's also procedural. So you have also to make some control flow. So it's not so easy to deal with it. And often it's not XSLT is not always quite understood, and some style sheets are not so good as they should be. It's not really scalable with large documents. It may be a bottleneck to use XSLT. There is no graphic user interface, and for InSpy it doesn't do the coordinate transformation. Now it's a comparison that was done by Thorsten Reitz from the data harmonization panel, and it's showing the same characteristic but maybe in a different way. XSLT is quite mature. It has a very good node for maturity, and it's proved by the number of tools using XSLT. There are really many processors using XSLT, so it's quite a mature standard compared to the other standards used for transformation rules. In a way, when there are so many standards, it's quite equivalent as no standard at all, in a way. And it's showing also the drawbacks, the fact that it's not only declarative, but it's declarative plus, so it's maybe why it's difficult to be used, and that the primary representation is textual, so there is no graphic interface and maybe not so user-friendly, but the schema language is XSD, and this is really nice because it's the format of InSpy schemas. So the result is that Cadastre succeeded to make InSpy data using this process chain. It was done, for instance, on parcels and addresses. And the conclusions, they are the conclusions from Just, not from me. XSLT for InSpy transformation, yes, but it works better combined with OGR and with PostGIS, as it was shown in the overview. It was an advice from Just also. Don't develop InSpy transformation in isolation, but in context of the global architecture. And the general advice that this overall approach in SDIN worked rather well. So if you have any question, please don't ask to me, but send the question to Just, because really he's the one knowing what is happening about this overall method. No. I should stop. So now some conclusions of this workshop. Coming mainly from the workshop that was held in Paris. So I will give at the beginning, it will be the biggest part of my presentation, the criteria to choose the relevant tools and methods, and there will be some other findings, but really the main part is the first one. So what are the criteria to choose relevant tools and methods? Of course, the first one is that the method and the tool should be able to solve the logical model issue. It should be able to transform table into trees. So if we want to have this nice inspired tree, we have seen there are several methods. The one-step method, for instance, Go Publisher, I think EL is able to do so. More or less Altova MapForce, GeoConverter, I think so. The two-step approach by making the transformation in table environment and moving then to GML. Generally, it's done using your database management system such as Postgre, and then using a WFS such as GeoServer or Degree. It's done also with ArcGIS for InSpy. It's done also with GeoMedia for InSpy. It may be done with FME also. And the alternative approach, the two-step approach, by moving first to GML and making transformation in XML, GML environment. We have seen the example with XSLT. Talent is based on it. ExoMS is based on it. There are some tools I have not classified because I was not able to understand how they really work. We had an issue in the workshop. It was with GeoKettle because GeoKettle was not really able to solve the issue. But the tool was presented by a user, so you never know if we were not able to use it well enough, but at least it was not so easy. Another criteria that is important is the transformation and download services. As said in the conclusion of JUST, the transformation is not something isolated. It must be designed in conjunction with the SDI and typically with the download service. Ideally, the schema transformation method should be adapted to the download solution. Typically, if you want to download by web feature service, it's quite logical to have the transformation in a relational database and using the web feature service, the method that was presented by Roy. But you can have also solutions integrated the web feature service, such as WS, and I think it's possible also with Go Publisher to plug the web feature service directly at the end of the transformation process. Of course, if you want to deliver data using just atom feed, you can use transformation that provide the GML files directly. A significant issue also is, should I make my transformation on the fly or not? So there are different transformation methods from the national schema to the user, and how to deliver and receive InSpy compliant data. There are generally three methods. The first one is the offline transformation. So you have your data in your national schema, and you make the transformation offline to another geodatabase in the InSpy schema, and then the user, by download service, will get the data. It's a transformation that is completely offline. The advantages is mainly about performance when delivering the data. The main drawbacks is that it requires the storage of the transformed data, and also the transformation has to be done for each version of the data. Each time you update your data, if you want to supply the updated data to the user, you have to transform the data and the whole data set. The other solution is the on-the-fly transformation. You have, once again, you source data in national schema, and the user at the end on internet. The user make a request in the InSpy schema. The transformation and download service will transform the request to national schema. The request will be sent to the national data. The data will be selected, and the data will be transformed to InSpy schema, and then the data will be delivered to the user. It's a purely on-the-fly transformation. What are the advantages? The advantages is that only the requested data is transformed, and as it's done on the fly, it may be very good for updating. The drawbacks are performance issues, and of course the fact that the data may be transformed several times. If you have several users asking the same data, the data will be transformed at each time. But it's a very useful approach if your data is continuously updated. There may be a combined approach. The combined approach is to make the transformation to the pseudo InSpy schema in the relational database, and to make the transformation to InSpy GML only on the fly. To make the second step on the fly. The advantages is that it avoids to store GML data. It's the main advantage. It avoids the storage of GML data. So when to use on-the-fly approach, the main drivers, I think, are the update. If you want to make your data that is continuously updated, if you want to make the update available to your users, you need on-the-fly approach. The other driver may be to avoid storage of transformed data. It may be important, but on-the-fly approach generally is possible only if the transformation are relatively simple. With complex transformation, it may be quite more challenging. What are the approaches that can allow this on-the-fly approach? It may be done using web feature service. As shown by Roy, there are different methods, and these two methods, the transformation may be done directly using the web feature service. Generally, it can work only on very simple transformation. So with InSpy, I will say at the moment, when we are transforming our existing data, it's not really realistic. Maybe in future, at least I think in IGN, it's our purpose in future to make our data close to InSpy model to allow us some on-the-fly transformation. The other solution is to make the most complex transformation in a dynamic database views, and once again it's possible in this fact to have on-the-fly transformation. And there are, I think, there are also some other tools, such as especially the tools that I think I forgot them. They should be. I think it's allowed also by some other tools. For instance, I think Go Publisher, it's possible, and possibly also the ELF Humboldt Alignment Frame Editor, the tools that make the transformation in one step. They may allow on-the-fly transformation. One of the other criteria to be taken into account is the expressivity. It's the richness, not your own richness, but the richness of the tool. The richness of the tool in transformation operations. For instance, there is this table that is coming from the comparison that was done by Thorsten Reitz in the data harmonization panel. The expressivity, you can see some results. For instance, FME, that is the most expressive. During the workshop in Paris, Ken Bragg told us that they were even so expressive that it may be almost a drawback because users may find difficult to find the right, the relevant operation to be selected. There were so many operations. But on the other hand, for instance, during our presentation, the Altova map force was considered as not expressive enough, because Altova map force is a tool that is made to transform XML to XML and has no special component. So for the geometry, it was not enough. So it's a criteria to be taken into account. Generally, the tool should be rich enough, or at least if it's not rich enough, it should be extensible, for instance, with open source tool. Another topic is about the knowledge. Of course, generally, if you have not big experience in schema transformation, generally you will prefer a user-friendly tool, and a user-friendly tool generally means a graphical interface. So a tool using a schema with graphical representation is generally more user-friendly. But of course, the other solution is to get training. If you want to use a train you don't know, you can also train yourself. Or not train yourself, but ask training to someone else. The technical state of play, what does it mean? It means that your transformation solution should also be based on what you already have at home. For instance, if you are equipped with S3 tools, probably you will choose ArcGIS for Inspire. If you are equipped with GeoMedia, maybe you will choose GeoMedia for Inspire. At least there are some drivers. Or if you have already an FME license, you can think about using FME. It's this kind of things. You have also to think about if you like to have something that is rather integrated. For instance, ArcGIS for Inspire if you are a S3 user, or if you want to combine the advantages of each tool. I think it was the experience in Cadaster by combining OGR, XSLT, PostGIS. Some people are more clever to combine different tools. It's the same for each tool, but it has to be considered also for schema transformation. Another criteria is the process, can you make it automatic? Of course, in the schema transformation, the first part, to take the source schema, the target schema, and to define the transformation rules, it's a manual process. I don't think, regarding the complexity of Inspire schema, that is something that can be automated. So it should be manual. But then you have to run the transformation rules on the data, and this part should be made automatic as much as possible, especially if you are a big data provider. Of course, for a small data provider, it's not so important, but for instance, for NMCAs, we have lots of data, and the tool, you have to choose a tool that can be called by command line, or the transformation rules may be exported, and you can batch the process, make a batch of the process. The idea is to avoid the necessity to have an operator opening files in the tool and running the file, the transformation rules, and closing and things like this. Another topic, of course, is commercial or open source tools. I'm not going to detail this because it's not typical to schema transformation, but it's also a criteria of choice for schema transformation also. Some of the findings, we had a discussion about what is missing about schema transformation. Some language for schema transformation rules. We have seen, in fact, they are not missing. There are rather too many. There are so many language for transformation rules, so no one is really widely used and widely recognized. And it might be useful to supply information to users. the idea will be to supply the user not only maybe the transform data, but maybe also the transformation rules. It might be useful in some cases. The constraints are not included in the target schema. The target schema includes the feature type, the attribute, but not the constraint. And it might be useful to check these constraints as soon as possible. And it would be nice to check them in the transformation process. Of course, we are missing validation tools for the transform data. Schema transformation at conceptual level, it's still a research topic. It was typically the research topic of model-driven WFS, and it was also a research topic for COGIT, our laboratory about cartography in IGL. And what is missing also is client tools to handle the inspired transform data. And maybe it might be the topic of another workshop later. Because really, once we have transformed the data, how users will use them? How can they integrate them, make application with them? It's also the topic of the ELF project. And if you want to know more, there are lots of presentations about the ELF project this afternoon in room 3 about the other cluster area between Czech Republic and Poland. On Wednesday, about experience with publishing inspired data for use in application. And on Friday, there is a session about ELF in general, the ELF platform, the current status and future development, and the GeoTools. And if you are interested in matching tables that are the starting point for schema transformation, I give myself a presentation about design and use of matching table to prepare schema transformation. So thanks for your attention, and of course it's half past midday, but if you have questions, I think we are here to answer the question. Okay.
Your question for Richard. So when you were showing the application from Snowflake, we can see there the target XML path.
Yes.
So you need to introduce all this stuff manually, or for example, you can use a kind of import and matching table or something like that in order to.
You don't have to type anything in co-publisher for the mapping. So once you set up your configuration in Publisher, is you point to a schema or a set of schemas, and co-publisher is intelligent enough to understand the structure of those schemas, and you'll be given a drop-down list to choose from. So if you start mapping, you have a little drop-down list, and it gives you all the relevant feature types or properties and attributes you can map to. So you don't have to type a full XML path. That's how it's being translated internally. Behind the scenes, it's all translated into expat standards, but you don't have to type anything for your mapping.
Vanda, you had a question?
I'm afraid it will be for another workshop, which is what to do. So once making this matching, and if we match to a target schema that may be the core schema for Inspire, but it also may be an extended schema based on the core. So questions related with that, and once they're on the databases from where we start, there are more than what is on those schemas, what to do with the remaining data, and what to do on the opposite side when data that are not on those databases are also on the target schema. Because, yeah.
If the content is not the same.
Yes, because if the target schema is one of, let's say, Inspire core data model, and you are doing this in the context of implementing Inspire, if you have only data sets more than what is considered on the board as the minimal, then we risk to do a lot of work that for a certain application in practical world, it's not enough. There is a reason why you have more data than the ones that is filtered out.
It's in a way, it's the choice of the data producers. Either they implement just in SPI, it's their legal obligation, and some information is lost, or they decide to be more ambitious and to extend the SPI schema in order to publish the totality of the information. But at the moment, the decision is up to data producers. There was a question?
Yes, I have a question to Richard. You're talking about matching tables and then use those as a basis to do the transformation. So that actually means that the real transformation is like saved into. What would you recommend about showing the transformation to other people? Would you recommend that you always update the matching table? Because as you explained, you have questions like in France. So I guess you have to make sure that either the transformation is like human readable, or you make sure that the transformation and the matching table are in sync. How do you do that? Is that just a matter of discipline? You make sure it's always updated, or what is your experience? What is your advice?
In our experience, in just talking about co-publisher, is the data transformation is reasonably easy to understand. It's a graphical interface which shows you per table how the mapping actually works. Purely from sort of interoperability, from talking to some kind of external customers or taking a data modeler who doesn't really have knowledge about particular software, Excel is almost the common language. It's quite easy to have an Excel sheet open, or even what we've done in the past quite a lot is just use one of those, whiteboards, and just try to just do a little mapping exercise on a whiteboard and talk to a data specialist and domain specialist and say, what do you actually mean with this? How does this translate into this? And we just sometimes write it down in normal words. One aspect, of course, around that is language. At Snowflake, we have about 15 nationalities, so we cover quite a few languages. But when you have something like maybe a Polish database and all transformations are described in Polish, for example, that may be a sort of obstacle for us as a UK-based company to understand exactly what is meant. So my advice would be, if you're using matching tables, but you may touch on that in your presentation around the matching tables, is to use a language. Well, you have to agree on a language that you both parties understand, be it your national level or in English or in French or whatever language you use, or using a almost more expressive language, using logical SQL language. So using a more technology-based language. Some of the matching tables we received from France, they contain a very sort of logical sort of explanation sometimes. Like, it literally says, if this column in between like little parentheses equals this, then next line, this value equals this, and if not, it equals that. And that's a more sort of a logical way to express those, a more like a mathematical way to express those transformations. And that's, well, they say mathematics is this sort of universal language, but it works quite well in that sense. Yeah. Does it answer your question? Yeah. Okay. Yeah.
Any question? Or no, it's Thomas that asking questions. So many thanks for attending this workshop, and if you need more knowledge and information, you can go to the presentation about ELF or visit our website where there is all this knowledge about the schema transformation.
Okay, great.
Yeah.
Thanks.